This is AQA A-level chemistry and it's the alkanes topic from year 12. This is part 6, the final part of this topic review, and in this video we're going to focus on ozone and free radical substitution mechanisms. So, as always, I'm going to recommend that you try each task, see how you do. We've got a lot of information here to think about. You may already know the answer at the bottom, but you could pause and read through and see what information you can get. So what is the formula of ozone? And it tells us in here that ozone is made up of 3 atoms of oxygen. Its formula is therefore O3. So, write an equation to show the formation of the chlorine radical. Think very carefully. Now, this is where people often go wrong because we're so used to breaking down a chlorine molecule. But when we talk about the ozone layer being broken down, it's in the context of chlorofluorocarbons. So you might be given one to break down, or you might simply have to come up with a formula of a chlorofluorocarbon. It's really simple. It's a halo alkane with at least 1 fluorine and 1 chlorine. And when you break it down, we end up with a chlorine radical, and we have a radical of whatever else is left. So we've got our CH2F radical and our Cl radical. So how does this react with an ozone molecule? Well, if I take my O3 and I react it with a Cl radical, the Cl radical is going to rip away an O. So we're going to end up with ClO, still a radical, but we've got O2 produced, which is stable. And then a second equation. Well, I've now got a ClO radical, which is very reactive, very unstable. So this time that reacts with an O3 molecule. That makes a Cl radical and 2 O2 molecules. So you're possibly already beginning to see the issues that arise here. Overall, suggest an equation for what happens in the breakdown of ozone to oxygen, and why is this alarming? So, to explain it as fully as I can, I'm going to put down those 2 equations from the mechanism, my O3 and Cl radical going to O2 and ClO radical, and my ClO radical and O3 going to a Cl radical and 2O2. We can get rid of spectators. I've got chlorine radicals on both sides. We've also got ClO radicals on both sides. And that means when we combine these together, we have 2 O3s going on to make 3 O2s. So why is this alarming? Well, if this is happening, that there's nothing else actually getting used up in the reaction, we can have a huge amount of ozone broken down to oxygen. And ozone is absolutely vital to prevent UV rays reaching us at ground level, preventing skin cancer. But if it can go on for thousands of steps, we're losing huge amounts of ozone. It breaks down to O2, which is fine. It doesn't cause us any harm, but we don't have the ozone layer that we need. Final question on this video is, what's the chlorine radical acting as? Well, the fact is, it's not getting used up in reaction. We generate it and then we regenerate it and we regenerate it. That means it's acting as a catalyst. That takes us to the end of this video and the end of this topic. Thank you for listening and goodbye.